While developing for MapleStory Worlds, you may have come across several functions that seem to have the same functionality, but seem duplicated, just with the AND wait or the async prefixes. You'll likely have seen this functionality most commonly in services that involve loading of data, such as resource service or data storage service. The AND wait and async prefixes have to do with whether the execution of the code is synchronous or asynchronous, and depending on which you pick, may have large impacts on your overall approach. Let's learn all about them today. First, let's talk about synchronous execution. Synchronous execution has to do with sequential execution of your code. So line by line, it will be executed in sequence. So imagine I'm 9heart and I'm really hungry and I want some food. And in the distance, I see a food truck. But for this food truck, there's a huge line. So I go up to the food truck, but I'm forced to wait. So the person at the very front of the line gets their food first. Then as that person leaves, the next person goes, and the next person after that gets their food until we finally get to our food. So in the scenario, we have to wait our turn, and each person gets their food sequentially, and we are waiting until we finally get our food. Now, finally, it's our turn, and 9heart finally gets his food. We can see the synchronous type of execution in play in this code example here. We'll start with the very top, and line by line, we'll go down in sequence. This is a standard execution that you might be more used to and isn't really something new. However, we have the ability to wait and pause our code before we move on. So in this example, we have an example of we're shaking the camera, but we're waiting a little bit before we reset our camera position. So first, in this bit of code, we will shake the camera, then we'll wait 1 second, and then we will reset our camera position back to 0. Here we can see that the wait keyword will allow us to pause our code execution for 1 second until we execute the bottom code. This same concept is also used in data storage. So here we can see the set and wait function, and this allows us to wait for this data to be set. And until this data is fully set, or there's some sort of error and we have to return, it will not continue down the execution and will wait for this to finish execution. Same thing for the get and wait. So previously we had the set and wait, which will set the grade key to the value A. And in this next line, we can see that we are retrieving that grade, which should now have the A value that we stored. But the get and wait will pause our code execution until we fully retrieve that data from the server. And finally, we log out the final grade, which of course is A. So when is synchronous execution useful? Synchronous execution is useful when there's a strict deterministic order of operations, meaning that before we execute the next line of code, the previous line has to be fully resolved. Otherwise, there will be some sort of error because our next code depends on the previous lines. Synchronous execution is very straightforward in terms of debugging. It's very easy to track what's going on, and there usually isn't any kind of issue of certain code being executed first or last. We know what executed first and then what executed next, and we can check more easily for issues in between those lines. However, this also blocks execution. So especially in the case where we saw previously with the wait function, where we are waiting for certain events to load, for example, if we're loading data or if we're waiting for a sprite to load, that all blocks execution until we fully load in the data that we need. This also has poor scalability under high latency tasks. So if you have a bunch of lines of code that each will need to load in some sort of data, then this becomes a problem because now your code is taking a really long time to load in the data that you need. So here's an example of something that can go wrong with synchronous execution. So in our first line, we see that we have a show message method. This show message method, let's imagine, has some sort of log to the console. Now we are referencing our test component inside of our target entity. But if our target entity is destroyed, for example, so in our next line, we will wait 3 seconds and then we will show the message again. But in between our wait and when we go to reference our entity again, it's possible that our target entity is now destroyed and we can no longer reference our target entity because it doesn't exist anymore. So our game states can change in between our waits. So this is where code can get unreliable with these kinds of wait executions, because it can get problematic if you don't track what's happening after the wait, and game states can change before and after the wait. So in this case, our entity no longer exists anymore, and that becomes a problem. Waiting can also be inefficient for large collections of high latency tags. So here we can see that we are retrieving a bunch of data from our data storage service. Side note that this is not the best way to load in large groups of data. Instead of individually getting your data, I would recommend using a batch execution. But for the sake of example, let's imagine that we're loading in each data one by one. So we are loading in one by one, and we're going through all of these lines until we get to the end. But how long before we finally load in all this data? It could take a long time because we might potentially wait for all of those lines of code to execute before we finally get to the game itself. Here's another example of something that could go wrong when utilizing asynchronous execution. Waiting in updates may not necessarily work the way that you expect. So let's take a look at this code. We have two logs, and in between we have a wait function. What do you think will be logged out to the console in this scenario? The expectation would be that between test and test 2, there is a 1 second wait, and then immediately test is logged after that, and then the next set we're waiting in between test and test 2, and then again we are waiting in between test and test 2. So there is a sequence of test, wait, test 2, test, wait, test 2, etc. But if you actually run this code, this is not what goes on. So what really happens when you run these lines? We get an output that looks more like this. We have 3 tests, 2 test 2s, and another test at the end. So why is this happening? Well, the reason why is because our update will continuously run. However, the wait execution will not pause the update's next execution. It will pause the update's current execution. So the next time the update runs again, it will still run every single frame. However, it will delay 1 second before test 2 is logged out. So what's happening here is we had enough time between 1 second to log out this first line 3 times. Then between the first test and our second test, 1 second has passed, so test 2 is now being run. Here we can see we have test, and then in between test and test 2, there is a 1 second wait. Then again, with the next test, it's still being run every frame. However, until we run test 2, there is a 1 second delay here. Hence the reason why we have this kind of output. Because every frame, our test is being logged out to the console. However, there's still a wait in between the current run of update. Okay, this time, let's take a look at asynchronous execution. Asynchronous execution allows us to schedule tasks in advance and then perform other tasks in the meantime while that code is run. So essentially, we are able to run 2 lines of code at the same time and not have to worry about the code that's running in the background, and we can get a notification that that code has finished executing, and upon finishing that execution, we can then run a different line of code. So here's Nineheart again, and this time he's sitting down on a table and he places an order from the menu. That order goes to the kitchen to be processed, and while that order is being processed, Nineheart does other stuff. He reads a book, he plays games, whatever he does, he will do while the order is being processed and cooked. Once it's finished, then the output from the order is delivered back to Nineheart, where now Nineheart can process that order and then fulfill the execution. So here's what asynchronous execution might look like. So we're going to retrieve our global data storage, and we're going to set our current power value to 20. And we're going to call our setAsync method from our global data storage. And we're going to set our power value to the string version of our power, which should be 20. And then we're going to pass in this function. So we're assigning this function as a variable of our callback. And our callback now stores this function, and we're going to pass this callback into our setAsync. And what this allows us to do is it allows us to tell our setAsync function to call this function after it's finished executing our setAsync function. So after we set the power value, then we want to execute this code. Notice down here that we have another log, and in this log, we're simply going to output our power value. we can see that our power value log is the very last line of our execution. However, in our console, it's the first to execute. And the reason for this is because our callback is passed into the asynchronous function, and until our asynchronous function is finished executing, we can continue running our code. So while the set async was running, this next line of code ran. And then after our set async was complete, then we called our second log completed save. So while this asynchronous function was running, we logged out this to the console. Once it was done, we logged out complete save. So when is asynchronous execution useful? Well, asynchronous execution doesn't block you while you're waiting on input or output, and allows you to concurrently run operations together and not have to wait for the previous execution to finish. This allows for more faster code and doesn't require your players to wait for you to load in data or execute on different code, and allows your code to be a bit more responsive and not have to wait for all of your code to execute first. The cons for this, however, is that this introduces more complexity with the callback semantics, and we'll get into how this looks in a little bit and how confusing this can get. And this, of course, makes debugging a bit harder because we don't know what will execute first and what will execute last, and it's hard to keep track of when something goes wrong, when it went wrong, and from where it went wrong. So let's take a look at an example. First, we have an async set and we have an async get. So in our first code, we have our set async, and we're setting the power value to our power. So our power is 20, and we're going to save the string value of our power. We have our callback function again, and we're going to log out completed save when this is finished executing. We have our async get, where we are retrieving the power value. And once it's finished retrieving, we're going to log out our retrieved value. So in our code, we can see that our completed save ran first, and our async value for our get ran second. So here our set execution runs before our get execution. However, what happens if our get execution runs first? So this time the order changed, and now get runs before set. And because both of these are asynchronous, there's no strict ordering, and whatever gets finished first is what gets called back. So the issue here is that if we try to get a value first, we may be operating on old data or inaccurate data when we intended to first set our value and then we wanted to get it. Let's imagine that we set our value to 30 now, and previously it was 20, but we changed the value and we updated our power to 30, and we run this again. This time, our get operation went first before our set operation. So when we got this value was still stuck on 20 when we wanted the value of 30 that we changed up here. So in this way, asynchronous execution can become problematic if you try to use asynchronous execution in a scenario where order matters. So if order matters, avoid async. And that's everything we have for you today. Hopefully this cleared some confusion surrounding our synchronous and asynchronous API, and you now have a stronger understanding of API that depends on timing or some form of delay while we wait for information to come in. Happy creating!